we're supposed to do this part by yourselves at the end of the period. So you say your monthly utility bills, pull this out, has a mean of 70 and a standard deviation of 8. You want to find the z-scores that correspond to these three utility bills. These are your x values. Now, for those that did, anybody not do yesterday? Yeah, just grave it, right? So we started out the same way we do in Algebra 2. I want to sketch. Put your mean in the middle. Put your 1, 2, and 3. I want you to see where there's negatives, where there's positives. So we had a mean of 70 and increase at 8. And decrease it, go down. Okay. So you get a feel for where their negatives and positives are. Okay, now, for my 60 is going to fall right over here. Approximately, what should that z-score be? Negative 1.25? That's a good approximation. Is it less than half of my graph or more than half of my graph? That they're better than. So less than half of my graph, it covers. Think of percentiles from 0 on to 100. So we're going to use the formula that we learned, and we're going to calculate your z-score. So we're going to take your x value, which these are your x values. There's your mean over the standard deviation. So what did you get for a z-score? Negative 1.25. Okay? And it was exactly, because I know Shayla did the exercise, but I was just looking for an estimation. So negative 1.25. Does that make sense? Yes. Now, pick up your table. Your area is always the area to the left. Do you see the front? You see that little graph? You see it shaded into the left? That's because whenever we look up a z-score, it's the area to the left. Now, if we were looking for a percentile, we would have to start at the 0, add those percents up, and stop right there. This table does this for you. It gives us the area to the left of that z-score. So if you look up the z-score of negative 1.25, tell me what your area would be. Everybody look it up. This part's not in your book, but I want you to see the correlation. 1.1056. Did everybody get 0.1056? What does this represent, 0.1056? It's 10.56%. It covered 10.56 of the field. It's better than 10.56% of the utility bills here, if we could kind of compare your utility bills. So in a percentile, it's ranked here. All this area, if I added it up, adds up to 0.1056. Remember, your total area is 100% or 1. So it's about 10.56, 10.6%. That's how much area is to the left of this. Now, it doesn't mean a lot to you now, but I want you to see the correlation when we do this. Okay, let's take another x value, an x of 71. 71 falls approximately here. Is it going to have a positive z-score or a negative z-score? What should its area be very close to? To what? How much of the curve does it pretty much cover? Half, just a tiny little bit more than half, right? So should it be greater than 50% or less than 50%? Greater. So let's find your z-score. 71 minus 70. See, that makes it a positive value, doesn't it? Divided by 8. What's your z-score? 2 decimal places. 0.13. Everybody get 0.13? Did you do this yesterday? Before we left? Yes. You got 0.125? Wait, let's put this in. 0.125?
I got 2.1. Yeah.
Right, but we're going to have to go to two decimal places because your z-score chart is two decimal places. So 0.125 is fine, but if we're going to look it up on the table, two decimal places.
So then 0.13.
1.3. Yeah. So we're going to keep your z-scores to two decimal places. And didn't we say this was going to be real close to the zero? So look up 0.13 and tell me what your area is.
5.56.
Okay, give me the 0.5517. Everybody get this? So if we move this, isn't this 55.17%? Didn't we say it was going to be over 50? So 55% of it falls to the left of this. We said, yeah, it would be a little bit greater than 50. It covers a little bit more than 50% of the curve. Your last one, 92. Look where 92 falls, all the way up here somewhere. So is this going to be an unusual entry, or will it be usual? Unusual. It's falling between 2 and 3. So when my x is 92, my z-score says 92 minus 70, it makes it positive, over 8. What's my z-score? 2.75. Thank you. Oh, and didn't we say it would be real close in between there, a little closer to the 3? Now, when you look up this area, before you look it up, what do you expect it to be? Greater than 80%, right? Because all I got left is this little tiny piece up here. Remember, when we really make the curve, that little plus and minus 3 is a little teeny tiny thing out there. So we should really almost have most of the curve in here, shouldn't we? A good probably 98, 99% of the curve in there. So look up this z-score, 2.75. And tell me what you get. 9970. So percentage-wise, 99.7% of the area falls to the left. This is a very tiny area out here. We make it look bigger because we need to fit things in our chart.
So the chart helps us find the percentile?
The chart is giving you your percentile. It's giving you your area to the left of that z-score. Okay. And we're going to work more with that, but when we first introduce z-scores, I like to use the chart because I like you to see how it's related to the curve that you know. With all those percentages on there, we can use the table instead of those percentages. All right. Questions at all on this? Now, a very good way to compare data sets, not just variability, but data sets alone, is using z-scores. Okay, if you're going to compare two different data sets, again, we can compare the variability by the coefficient of variation. We can know which one varies a little bit more than the other, but we can't compare one to see which one actually does a little bit, has a better standing than the other. So according to your table in your book, it's a little table on the left-hand side. It gave you the heights and the weights of men and women. Now, it would be silly for us to compare the heights and the weights of the men and women without comparing in their groups, because you really can't compare the men's weight to the women's weight. So you want to compare them within their group. And you can do that with their z-scores, and then you can compare their z-scores to see how did they fit in within their groups, because you can't compare them otherwise. So you have the men's heights and the women's heights, and of course, yes, they're going to be different. And I would even expect the men's standard deviation to be a little bit greater than the women's standard deviation, right? I mean, if you think about it, because women probably are closer to about the same height, where men are kind of more spread out, their standard deviation has more variability. And when we first looked at this, we looked at variability. Now we're going to see if we can compare them where they exactly fit within their own group. And we do that by a z-score. So if we take this and we make a chart, and you can put your mean up here, this will be your men's. Add your 3, subtract your 3. This will be your women's. They both have the same setup. Add your 3, subtract your 3. And we take a look at this, we can figure out where they compare. Now, take a z-score for a man. In the men's, 6 foot. Okay, and you want to see where they would compare. So 6 foot, and this is in inches. How many inches is 6 feet? 72 inches. So right away we have to convert this to inches. So 6 feet is 72 inches. So we say, okay, 72 inches, and this was 3, it's probably right along here. Pretty close to the mean. Most of your men are going to fall within plus or minus 1. So plus or minus 1, we're mostly fall in between. So we do their z-score. 72 minus 69.9 over 3. And we find their z-score. So find their z-score to be 0.7. And didn't we say it was going to be right before the 1? Right? Now we're going to find your z-score for a 6-foot woman. This is also 72 inches. Now if I add 2.6 and 2.6, so this has become 66.9. So a 72 inches is pretty far up here. So it's pretty far up here to be a 6-foot woman, right? So let's find their z-score. Use their mean, use their standard deviation, and locate their z-score. So their z-score is 3. Okay. Now you can compare their z-scores. Guys, seriously, you can compare their z-scores. Look at the interpretation. This is the most important part. The z-score for a 6-foot man, when we noticed it, was within 1 standard deviation of its mean. Meaning, most of your scores fall within plus or minus 1. He's a typical height for a male. The z-score for a 6-foot woman was 3 standard deviations above the mean. This is unusual in the women's category. So, where I can't really compare, they're both 6 foot tall. How do I compare how they fit into their group? I have to have some other way to compare them. And that would be their z-scores. Yes, we can obviously see it when you make the chart. That's why as soon as you make your chart, you can obviously see where the difference is. And if you're looking for where they really use this, and you'll see in some examples in the homework, they'll say like a team has, they'll do like a football league. A team has 7 touchdowns compared to the mean of 3 touchdowns and standard deviation of 2. Another team has 20 touchdowns compared to a mean of 15 and maybe standard deviation of 2. Who did better in your field? So that's where you need to compare the individual z-scores and see which z-score is higher, because it's a percentile. You're better than that much of their group. So that's where there's a better z-score. Here, yeah, we obviously can figure out, yeah, it must be unusual for a woman to be 6 foot tall, but not unusual for a man to be 6 foot tall. You can also compare your grades on your exams based on relative to how your class did. You scored a 75, but the mean was 74, and the standard deviation was like 12. So you're very, very close to the mean. You scored an 80, and the mean was 80, but the standard deviation was 3. So how close were you to the rest of the class? So that's how you want to put everything like kind of in perspective when you look at a z-score. And that allows us to compare apples and oranges using our z-scores. There's probably a very good example with the football teams in here. Let me just cut this out for me. We're going to compare these two football teams. Now, if I I look at the Kansas City Chiefs and I look at the Tampa Bay Storm. Who has more touchdowns?
Tampa Bay Storm.
Oh, so Tampa Bay should probably be the better team, right? But I really can't compare these because this is an NFL team. This is an arena team. Arena football is very different. If you've ever watched them, they're very different. They do wear some padding, but they're crazy. And they do a lot of other things in there. So I really can't compare a National Football League to an arena team because they have different rules, different players, right? If anybody's ever seen those games, they're like wild. So it looks like they do better. But let's look at their Z-scores without even making our graph. Oh. I always forget that happens to me. All right. So let's compare this guy's Z-score. God bless you. So they had 63 touchdowns. This is their X. This is their mean. This is their standard deviation. Okay, this side of the room, compute their Z-score. This team and the arena team, this is their X. They had 119 touchdowns. This is their mean. Oops. And this is their standard deviation. Look at how this varies. Look at how this varies. We can look up their coefficient of variation too at the same time and see how much they vary. Their coefficient of variation, if you remember, was their standard deviation to their mean. Let's take a look at their coefficient of variation as well, because I think that will make a big difference when you see it. So, this side of the room, find me the Z-score. Because it sure looks like the Tampa Bay scores a heck of a lot more goals than the other team, than the Kansas City Chiefs do. So anybody come up with this Z-score? 2.75. Pretty high at the top of their field, aren't they? Pretty high. And what's this Z-score? 0.42. They're pretty much normal. Aren't they within the plus or minus 1? So technically, which team did better? Within respect to their field, the Kansas City Chiefs. Now, normally I look at this and I say, oh my gosh, that's like at least almost double of their touchdowns. But in perspective, in regards to the rest of their field, the Kansas City Chiefs did much better. Let's just do their coefficient of variability, and that might make a difference now when you understand how we measure these. Theirs was about 15.5%, and theirs was about 25.9%. Look at the variability in one team versus the other. Okay? So you really have to put this in perspective. Does this make more sense? It makes far more sense than the height thing.